Welcome to Beyond the Classroom with Dr. Trina Coleman, where we are broadcasting live on HBCU Smart TV now, as well as continuing to broadcast to our listeners on HBCU iRadio. We have with us today Mr. Laron Walker, is the CEO of MantisEDU, and he does some cool stuff with the Internet of Things, or IoT. So and his bio is about yay long, but we're going to cover some of it, starting with his HBCU roots. Yes, Mr. Walker went to Tennessee State University, and he has a bachelor's degree in electrical and computer engineering. So we're going to really get into some of the technology and some of the applications of it and how he got into the Internet of Things, which is a relatively new field, but his academic background kind of led him there. I'm going to take a pretty good guess at that. So Mr. Walker then went to Purdue. So he continued his studies to study electrical and computer engineering. And he's doing outreach. He has a nonprofit. He does robotics. And Mr. Walker he does a lot of things for the community, but he also does a lot of things for application and the advancement of technology. And once again, HBCU grad. Welcome to Beyond the Classroom, Welcome. Mr. Tell us a little bit about what you're doing, what you're working on, and first of all, why you ended up at Tennessee State. What was it about Tennessee State that drew you?
That's one of the things, yeah, and thank you for having me again and giving me the opportunity to kind of tell what we're working on here. So I'm a native Atlantan, was born and raised here, and I actually attended an engineering mag in high school in Atlanta called Frederick Douglass High School, which was one of the top performing schools in the Atlanta public school systems in its time. And it's before I go there, actually middle school, we had to pick a school, and they asked me to pick if I wanted to go to that school and if I wanted to be an electrical and mechanical engineer.
Oh, really? Okay.
I chose electrical because I like to play with wires. I really had no perspective. I get to Doug, and Doug was a bit ahead of his time. We had distance learning, back in the early 90s. Pretty interesting school, very highly, I took programming in the 9th grade. Some kids to this day still don't do those things.
Exactly.
We took the, AutoCAD and all those sketching and all those type of subjects back then.
Right.
And at one point, I was number 3 in my class. I was a pretty decent student, summa cum laude, but a poor student. And I think I was at the point, think about, it's around that time where it's second semester and you really don't know where you're going to school at yet because nobody in my family had ever done the college experience before. I remember this day where there was a seminar in the auditorium, and maybe it was a recruiter from Tennessee State, but literally somebody said, if you have 1,000+ on the SAT and a 3.0, you can go to school at Tennessee State. And that's literally how I went to TSU. I ended up getting a full scholarship to TSU. Got there, it was in Nashville, my first time really away from home. It was one of the best experiences I've ever had before. As you know, HBCUs provide a really nurturing environment for people like us. A lot of my friends from Atlanta went to TSU, ironically, because it's only 3.5, 4 hours away from Atlanta. And the cool thing about it back then is Dr. Rogers, who was our dean then, very good dean, but more importantly, he was very entrepreneurial and allowed for us to really kind of run things, man. As in this first summer there, we ran the summer pre-college programs, right?
Wow.
So he forced us, people on scholarship, to go out and mentor and support kids in schools. That was one of the first times where I went to schools, in elementary schools, twice a week as a part of my scholarship to help kids give service.
You got to work for that money.
Exactly. But it's like those type of experiences help us realize that giving back matters and allows the community also start building skills. So that was kind of TSU was where it all kind of began for me.
Yes. Well, that sounds great. And that sounds like an awesome mentor with foresight to understand what it takes to make you guys not just focused on the engineering, but focused on everything that, beyond the classroom, as I like to call it, the things that you do outside the classroom.
Now, without question, like on campus, we have, for instance, we always had these things called DLSs, Distinguished Lecture Seminars, where corporate leaders would come in town. And I remember 2 experiences, very interesting. So one time the CEO of Boeing was on campus.
Wow.
And they they had to speak that evening, but the entire day when they were on campus, their entire experience was student led. Right.
Wow.
And then once I remember a guy comes in and he was from the Army, and I was demonstrating my research to him.
Mm-hmm.
He was like, "You should come work for the Army." And I was like, "It's not something I really would do." And I remember the next day, for some reason, maybe I had to fly to town for an internship, and I was at a hotel where they provide you with like the USA Today paper at the front of your door. And the guy who I presented to was General Joe Ballard, and he was like the head guy in the military who had just asked the president for like a $2 trillion budget. And the day before, he was in my lab talking to me about working for him in the Army or something. I'm like, so those type of experiences, which I never got that at Purdue. It was a different kind of conversation, a different narrative there. But TSU was really a place where, you got to really be involved, kind of figure out who you were, and got put out there. So that was one of the best experiences I've ever had before.
Well, yeah, and you have a unique and awesome story about your experience, and that's one of the things about HBCUs. We all, in our own way, have something that we hold dear, or somebody that made a change or a difference in our life.
Sure. That
we remember even now, depending on how long ago we, graduated, but still that experience at that HBCU where somebody's coming in all the time, trying to help figure out a way how to make the students more excellent. They're already excellent students, but to add to that pedigree and to help them create that resume and that path of a career, not just from one job to the other, but to put them on a career track. And that's amazing that you had that experience. So after you found out who he was, what happened then?
I know that's when I really first started. Even to this day now, I follow people, right? And I figure out what they're doing to have that connection. So that was probably one of the best experiences in networking and connecting with people. That really wasn't my path that I was looking to go down. But I did realize the importance of connecting with people, make sure they know who you are, and then trying to figure out how if you ever cross paths with them again, to make sure that experience is remembered. So that was probably the lesson out of that experience.
Well, that's kind of what you and I did.
You never know when you're going to cross paths again and how you're going to connect with people. So that's really important. And
it's very important.
It is important. And last story I tell from TSU, which is directly proportional to kind of what's happening now, is that when I was in maybe a sophomore there, a grant was received by the Department of Electrical and Computer Engineering. And they started a new lab called the SCICE lab. It was for studying computer information systems. And I literally got paid grant money to learn how to write HTML. And out of that experience, believe it or not, I think it was two other friends of mine who were there. We learned how to write HTML, and we literally built the first website for the Department of Electrical and Computer Engineering as a part of that project.
Impressive.
And that was the beginnings of my learning about HTML, how to build websites, and really get into software development. Ultimately, that experience led to me starting a software company, which has been my profession now for the past 20 years. But again, directly related to experiences at TSU. And had I not gotten that experience, I probably wouldn't be in this chair today talking to you.
Well, I am glad that you got that experience. And yes, because you're doing some awesome things, and you're giving back tenfold. You're not just doing it just to, check a box off and say, okay, I did an outreach program.
We got to pay it forward.
Got to pay it forward. And in all of our own unique ways. And yours is, software, engineering, applications of engineering and technology, and curriculum and all of that stuff. So how did you go from writing HTML code, which still I'm sure you do some coding, to help, with your products and your devices and your gadgets, as we call them, help make that part cool.
So what happened was when I left TSU, I went to, in graduate school, my research focus was actually in the area of haptics. So if people aren't familiar with haptics, it's basically if you ever played a video game or something and you're playing a racing game and you hit a wall and that joystick vibrates, right? The study of using perception and to influence reactions is kind of the study of haptics. So in grad school, that's how I was studying. And that was one of the first times where I really started to truly connect hardware and software together, realizing the importance of both kind of happening. And that was really exciting. I often say that one of the things about my grad school story most people don't realize is that when I left Tennessee State and went to Purdue, I was actually in a direct PhD program. I was always told to get the highest degree. So I spent nearly 5 years in grad schools going for a PhD. And I guess I have what most people say ABD, ABA dissertation. Because what happened is that when I was in that final year of working on that journal paper, I realized that teaching and research in that regard was really my path. And I had started a company building and supporting technology. By that point, I had gotten the bug of things that were tangible, that you could touch and feel, and leveraging software to make that happen. And so that was kind of my journey. Then what happened was I really got exposed to the notion of the K-12 space around the time of the Race to the Top program. So that was a program that came out with the federal government, really supported, and was trying to get states to really kind of move toward a common framework so that they can share resources and have common standards. And in looking at that, one of the things that we realized was that even going back to my undergraduate experience is that when it came to physical computing and engineering related principles, most of the places that we care about was sorely behind. There's still more tech today that's in, my junk drawer in my office that is in a lot of the classrooms that I came through. And if you take that back down to the K-12 experience, the schools that have a lot, and the schools that don't. Right?
Exactly.
And it was like, man, that's very interesting. And then even the ones that have access to technology, most of the companies that are supporting those schools, the things that kids are learning are not really truly aligned with what's happening in the real world in most cases.
Right.
And the experiences they're getting are very limited. And so
very limited.
Yeah. So I started to think about that and think about the resources that we had and said, who better but us to try to find ways to address that issue? And realizing that if we could find a way to take physical computing and real examples and get kids excited about it, getting kids to understand like how things work, we believe will get them excited about why things work. And so that's kind of what led us to our current journey. So we stood out to say, what if we could build solutions and frameworks that we could provide to the community that were best in breed, but affordable by design, that will allow for everybody to expose and get access to these things. And as they matriculate through their education, they can come out with portfolios, examples, and diverse use cases that can change their perception of what engineering really looks like. Because unfortunately now, when it gets to, if you think about computer science and coding, most kids think that's only robotics.
Right.
Well,
exactly. You write a little couple lines of code and you have this robot and you make it do stuff.
They can do stuff. Or you drop and drag. Early kids, you use a program like Scratch, which is amazing, by the way. I love Scratch, and we'll speak about that a little bit later. But most kids' examples in Scratch is, hey, have the cat rotate and turn yellow or blue. And that's the end of it. Or like when I was in high school, let's write a program to go and present prime numbers and, count from 1 to whatever. And you just see numbers in a loop going by. Right. And they don't realize that, there are other parts of this, right? We talk about AI, machine learning, you use Google Home and Alexa every day. Like there are algorithms behind that people write, and you can participate as part of that ecosystem. But if you go into a high school or middle school or even a college at this point in time, in most cases, we aren't working on those type problems that they can relate to and see. And I think that really puts a disdain on the industry. And more importantly, what I often say is that things that me and you would work on, if we were doing things in the industry, things that have become almost like an API call, something you can outsource. We have kids and students still try to build businesses and companies based on things that are free these days, like something I could pay 1 cent for because they haven't been exposed to it. And so that's something that I'm really trying to get involved with. And I think by doing that as well, since we are working on aligning to things that are happening in the real world, it'd be interesting to see like the number of corporations that like this approach. Because just like we face issues with building pipelines in schools, corporations have issues with filling pipeline for workforce and having kids that come out also be workforce ready. And so I'm trying to find a way to kind of coalesce those groups together as well. So there's a win-win on both sides.
Yeah. Some of the things that you talked about as far as students and these coding experiences and camps or whatever they're involved in or workshops, the conceptual stuff is missing a whole lot of times. It's like, how does this work? How do you do the logic to code? What? And if you don't get the logic right, you're not going to get the expected outcome. Then you have to go in and debug it and figure out where you messed up.
Yeah,
that's how coders are made.
It's problem solving, it's debugging, and a lot of our kids today don't have ability to build critical thinking skills to go through cause and effect. and help them figure out that, like I always joke about, a lot of engineers ultimately don't practice engineering. We pick different paths in the end, but at the end of the day, it's one key skill that we all have, which is problem solving, which can be applied across different industries. And, putting kids in situations where they can experiment, fail, understand logic, see cause and effect, and see it applied across a multitude of use cases, I think is interesting. And I think what happens is that once they do that, they realize that these skills are transferable. And that's one thing I don't think we're doing properly.
Yeah, they are transferable, but are corporations taking that into account? Because let's take, for example, one of us, you or me.
Sure.
We have a certain skill set that not only did we acquire certain skills when we were students, but we've had life experience to this point now where we see, we've done, we've, experienced, and we have a broader view on technology, on STEM, on, the engineering part that you do, but also more so about real life and what's needed, what's happening, and how to acclimate the public to, your devices, but also how to help develop those entry-level professionals to become, more agile in the spaces. It's like the workforce has like certain paths. Most companies have, we're looking for a blah, blah, a data analyst or a something, and you have to have done this thing right here. Otherwise you don't count as a data analyst. I don't count as a data analyst by a lot of company standards. And
but you can teach them.
I could teach them. Not only that, I could show them the darn dissertations.
Yeah, so you wrote the book.
I had to write code, to do that. And also I handle data sets. We all handle data sets. You handle data sets.
Sure.
So how does corporate America get to the point where they get it?
I think they're starting to understand it, because that was a huge disdain before around like people who maybe don't have 4-year degrees, right? Or people that
got 3 degrees.
Yeah.
I mean,
Yeah. So I think that now, from what I'm seeing, is that a lot of the effort and focus now is on, can you get it done, right? Like if you can come in and demonstrate that you can actually do the work, I think some of the other attributes are not as highly weighted as they used to be before. And that's the reason why I think it's critically important that for our students that, we have always focused on having a GPA and having the book sense and maybe having an internship, but there hasn't been a really big focus on coming in with a demonstrable portfolio. So if I were to come in now interviewing for that same data analyst job, and I can come in and show them the regression algorithm that I built before, right? Or how I was able to ingest this data and have it apply somewhere, or I was able to transform from system A to system B or normalize that data set. We have to have kids be able to not only speak to the vernacular of the science we're going after, but show they've actually applied it. And I think that'll get people geeked out around like, oh, you know what? That's cool. Well, yeah, maybe don't look a certain way here, man, but we can start working day one. And that's what we're not having. And then also what we're finding is that what's really I'm struggling with a lot, man, is that we've been doing a lot of work with elementary, middle, and high school. That's been a real focus of ours these days. And man, what we're finding is that on the high school side, man, the baseline for computing and these skill sets for high school students are almost the same as those of the middle school these days.
Wow. So what's going on?
Well, I think what's happening is that, you mentioned some of these newer fields we're describing. So we're talking about things like Internet of Things and data science and machine learning. One of the biggest issues I see with the industry is that we all agree that there's a workforce shortage of these skill sets, even people going to corporate jobs. Yet we assume that in the K-12 space that we're going to find these people to come and teach these professions, right? You have entry-level kids graduating now with computer science degrees, pulling 6 figures, going to work with, no experience. So if you can pull that sort of salary at that level, are you really going to go into a profession that's paying you $50,000, $60,000, $70,000 a year? So we're
not getting $70,000 as an entry-level teacher.
Exactly. Well, that's my point. So we're not going to fill that pipeline. One, two, we assume that these professionals are going to go and teach these courses, whereas in real life, these skills that we're describing typically present themselves through specialized programs. So it's the robotics club, it's the after-school camp, it's the STEM club, right? These things are a part of the general curriculum, right? They're not a part of math and science experience. And so we don't have the people on these campuses or schools that can teach these things. And so I think the construct is really flawed. And what's happening is
Yes.
that these kids are making it through ninth grade and 10th grade, never being exposed to these things. You know,
Mm-hmm.
by the time you get to 11th and 11th grade second semester, you've already kind of made these career decisions. Then somebody
Yes.
walks in one day trying to tell you, hey, you should write some code, and you don't have any sense around what that looks like. You're like, why
Mm-hmm.
should I touch that? So
Not
that,
only that, they're
yeah,
trying to get that high school experience in. They're like, okay, we
exactly.
got prom and we got some other stuff, and we, they're
If
doing
they're
the
there,
social pieces
and
as
then most of the
well.
tools as well, like, and we mentioned Scratch. Scratch is an amazing tool that has really taken over the lower levels, like elementary and middle, and it's pretty easy to kind of get involved with. So
Mm-hmm.
you'll find a lot of these young kids are learning about those tools because almost every product on the market is using some kind of drop and drag or block programming. So at
Mm-hmm.
least they're getting exposed to some of these constructs.
Mm-hmm.
And that's the difference. So it's like we got to find a way to reach back
We do.
and pull that forward,
We do.
because I think the couple of the generation of kids that are in high school now who haven't touched these skill sets, it's a really big issue.
It
And
is.
it's amazing to see how much of a problem it is. I've noticed that, and we ran 3 or 4 camps over the past 6 months or so,
Mm-hmm.
and every time it's the same experience, and it's really disheartening.
It is. Well, let's take a break right now. Listeners, viewers, you are listening to Beyond the Classroom with Dr. Trina Coleman, and we're going to take a short break, and we will be back with Mr. Laron Walker to talk more about the Internet of Things and coding and all that cool stuff that he does, and how we're going to reach out and get these students on board. Okay, welcome back to Beyond the Classroom. And we're speaking with Mr. Laron Walker, and we're talking about students and skills and how to get them to a point where they're learning the right things and they're experiencing the right things to help them with their critical thinking skills, to help them become the next Laron Walker, who's like loving playing with gadgets and writing code, making things work and doing those types of things that are application based and real world based. Mm-hmm. So Mr. Walker, I said I was gonna call you Laron. So Laron, let's talk about some of the stuff you're working on.
Sure. Let's do that. Yeah. So I think so one of the things like we mentioned, so we're playing in the space of the Internet of Things, as you described earlier. For those who are not familiar with that idea, it's basically taking all these devices you use, right? Whether it be your Google Home, your Fitbit, things that rely on the internet to transmit information.
I can go left or right and pick up something. I got a Bluetooth speaker right here that I can drop in the water.
There you go. So it's collecting
it'll connect
data
to my phone, my car,
it's making
whatever.
Decisions. Exactly. It's using the cloud, this big network of computers to make decisions.
Yes.
And we're using these things every day. But for the most part, you don't hear this domain language being leveraged in the K-12 classroom, right? Kids are not learning how to program, build, and create devices along those lines. So that's one of the things that we're focusing on is getting kids understanding how, first of all, that the fact that we can make and build devices, that's a career path, right? As a hardware engineer, as a product designer.
And a patent if you come up with something new.
All right, you can get a design patent, you can get a utility patent, you can write firmware to support that. But then once the device comes online, right, you can write software, right? So you like playing with these apps. That's a skill set. You can build a mobile app, you can build a native app. It can go cross-platform, iOS and Android. But more importantly, if you combine this hardware and this software together, right, you're now playing in this space of Internet of Things, which is a highly growing skill. But then once you have this data, what do you do with it? You know, how do you get it to the cloud? How do you act on it? How do you apply algorithms there? So that's a space that we're playing within. And what we're doing is that we're taking tools like, for instance, we mentioned Scratch earlier. Scratch is a very popular tool. Around 40 million monthly active users use the platform. Wow. And for the most part, the experience is using block programming where you're dropping and dragging things to make algorithms. And then you connect with computing devices. For the most part, kids will build programs. They will take that program and compile it to some source code and put it onto a device that runs disconnected, right? And that's a pretty interesting experience, but it's in some ways a limiting use case. So we did one thing a little bit differently. We took the program Scratch, which historically runs online. You mentioned devices that you have in your office like Chromebooks, et cetera. For the most part, they require for people to have internet connectivity, when in some cases that's not possible in the communities that we serve. Right. So we wrote a version of that software that runs offline without having to have internet connectivity, one, so we can work on low resource environments. Two, we made it so that our program could not only do the drop and drag programming, but it could connect to sensors in real time and multiple sensors, right? So now that enables us to create real use cases. So as an example, one of the popular things out today is the notion of sustainable foods. A lot of people focus on the science of hydroponics and aquaponics, which is, using nutrient-rich water to grow plants and vegetables. Now, as a part of that process, there are a lot of things that you need to support, right? You need to measure things like your environment. So one of the sensors we create is the sensor I have in my hand now. This is a circular Bluetooth sensor. And this sensor essentially is a beacon, meaning it radiates data into the air. But what's nice about this sensor is that it measures the ambient light. It measures the temperature of the environment. It measures the humidity.
That's pretty cool.
Pressure, all wirelessly.
And listeners, if you're not watching Smart TV right now, he's holding a sensor. It's about the size of 2 poker chips glued together.
Like size of a poker chip, and it's a sustainable sensor. But what's cool about it is that, so now when you're looking to grow this plant, right, here's a real-time data stream. We've made connectors so that this particular sensor hooks into tools like Scratch, so kids can actually operate with data in real time.
That's pretty cool.
That's one example. Another sensor I'm holding up now, this guy here is called a moisture probe. Okay. So again, when you're growing plants, what do you care about? How much moisture is in my soil? What's my ambient temperature? How much UV light do I have? Another sensor that comes into play to allow for you to measure and get data in real time. And
now, so that can be used not only in the hydroponic environment, but like if somebody wanted to put one in their flower bed.
To your point, so we're working right now with a major retailer on launching this as a consumer product to be able to help you basically put together a care plan for your plants that are temperamental, right?
Yes.
So we take this sensor now, we bring in like a Wi-Fi gateway, and now you have a smart device that allows you to measure and control your plants. But think about that. You just came up with that use case by seeing me hold it in my hand, not knowing I was working on it. So imagine what happens when you expose kids to this tech, allow for them to use it, experiment with it, understand how it works, and they start to dream about it.
Because it's ultimately something that will solve a problem for somebody.
It solves a problem. And that's the thing. So
that's basically what technology is
that's what it is. And so
make something new or to make something better. That's what I tell my kids.
Now, we'll hook them into Scratch. and let you get data streams. But this is what we do differently now. We've made blocks now that do things like send to the cloud or send SMS message or make voice command. So now a kid can be inside of a tool like that, having cause and effect relationships, having the computer speak to them, having them send text messages. So we're doing the same type of things that you're doing with your smart speakers, your Alexas and your Google devices, but they're actually able to see it go end to end. And so that application of that is what's different now.
Yeah.
Another example, this is another sensor in my hand. We call this guy the Sensor One. And this essentially is a small device that's a multi-function data logger, and you can plug different probes into it. So in this case, I just plugged in a temperature probe.
Okay.
Right? So wireless temperature, but this guy does temperature, pH, conductivity, turbidity, all these different probes that you can read. And so going back to the example now we described with the hydroponics or aquaponics, when you're growing a plant, what do you care about? You care about the moisture, pH, you care about water quality.
Does it need sunlight?
The sunlight. So if you combine all these things together now, I can now actually go build a control and monitor a smart grow system. And so
yes, you can.
That's example. So we'll take in the idea is that we build these modular examples that are focused on what's being taught in the classroom, an after school program. We get you exposed to the individual sensors, and then we try to culminate that in a real world use case. So in this case, you can go and spend a week on each sensor. And then by the time you get to the 4th week, you're working with a real use case. And we throw in one more piece there. We throw in a controller that can turn on pumps and valves to drive water back and forth. So now you've completed your control system. So imagine now if you're middle school or high school now, you wanted a science fair project, and you were to go and say, hey, class, you must use these sensors as a part of your baseline. Every project must have a mobile component, a cloud component, a control component, and you have to go and create something that's real and actionable. And now they're able to go through that process from end to end. Like that hands-on applied piece versus saying, hey, go to the board and let's integrate with some formulas and take the derivative. Like, what does that really mean without applying that? And I think that's the difference. And here's another sensor that I think you'll like, given your background. So this guy here is called the Modi. And
Modi. I like all of them, but let's hear about Modi.
The Modi is nice because people who like physics and things along those lines, this essentially is a Fitbit device. And what it does is it measures the gyro, so orientation.
Okay.
It measures acceleration in X, Y, and Z axis. And it has a real-time optical sensor to measure distance, right?
Wow, time of flight. So yes.
So cool. Literally, so in real time, I can go to this guy, connect to it, and basically, if I wanted to go now and have a kid do an experiment on, let's say a classification experiment, maybe they put this on their back and they're walking and they have to go write some algorithm to determine if you're walking or running, right? Or if you're doing experiments with robots or cars, you want to see how fast something is moving and how long taking, Newton's law, right? Or one of those guys and doing those problems. This gives you data in real time. Or it may be where if I wanted to go and simulate, maybe I'm a video game controller and I want to go and have this guy become an input to a tele robot or something. This could become a video game controller because I can model the orthogonal motion in my hand as a controller. But all those things now are available within this small form factor that people can use. And so again, just making these things available to kids in an interesting way, it's cool. And I always tell the story about even now with Fitbit, one of the more leading devices in the space. Actually, Google just bought one Fitbit for like $2 billion. It's one of the more ubiquitous devices out for monitoring for walking and running. But as a researcher, you don't get access to that data, right?
Right. No, you don't.
So that matters.
It does matter because when we're talking about the X and Y and all of that and walking versus the running, I thought about my days when I worked at Howard and climbing that hill, walking to the A building, up Georgia Avenue. It's a whole lot harder to get up the hill to the A building than it was to get down the hill. So, being able to measure, even if you're walking, the distance and the time. So the speed, the velocity, basically.
Exactly.
In the X and Y, because it's not a flat surface. And so you're walking on an incline. Whoops. Hard to, there we go. On an incline. And it's just the applications of it all. I'm getting excited about
but to that point though, just imagine if you were on that campus teaching a class in physics and kids had devices like this. and you can go give a challenge now and have them go out and collect that data, go and mine it, build algorithms, and do the prediction piece on that. Then
and
imagine now when they graduate,
they can calculate the slope.
Calculate the slope, right? And talk about the rise and the run and how it works. Right. And they can use the gyro accelerometer if they want to do integration to figure it out. Mm-hmm. If you want to do the more derivative approach, they can use the distance vector to make it happen. But now imagine when they're now going out to find a job now at a Lockheed Martin or Raytheon, they can speak about, yeah, you know what? I collected this digital data. It was kind of noisy, so I had to go provide this filter on it, or I had to throw out these anomalies. And just think about that versus them going in now and trying to draw some discrete math equations and explain that. It's a totally different scenario. And I think that if we had these sorts of things in place, I think you would find kids trying to figure those formulas out to make their code actually work. Because they can actually
I'd be doing the same thing. I'd be like, oh, let me figure out a way to make a new problem for them. Yes.
I think so. So I think to me that applied piece matters. And here's another cool sensor that we're putting together.
Hey, how many sensors do you have?
A lot of them. This is a partner. This company, they make these little pH and ammonia alerts, and these are for aquariums, right?
Okay, it looks like a lifesaver for those of you who are not watching a smart TV. Actually, it looks like a washer with different colors. So what you do is you put
this in your aquarium, and it has a reversible strip on it, and the colors change. So in this particular case, this is a pH strip, and the color will change according to this gradient when the pH is going up or down, right? Okay. The problem with this case is that it's a pretty cool thing. It's pretty ubiquitous, but it just sits inside of the tank. So if it's out of bounds, how do you work on that? What do you do with it, right? So we actually created a beacon device that actually, it's a color beacon. You put the strip inside, and this device floats in water, right? And as it reads the color, just like the other sensors, it beacons out the data, so you can actually get it wirelessly.
Okay.
Right.
While it's in the aquarium.
So now you can get pH, you can get ammonia, and we're working on a variant of the same sensor for chlorine.
Okay.
And again, like all these things that are just around us in the real world that, to me, if you're looking at some of the leading skills that are needed, data science, machine learning, programming, algorithms, all these examples of applications of doing that. And the last thing I'll show you, my little box of tricks here, we're excited about this guy as well. A lot of schools are working with 3D printing. And we mentioned robotics as being a use case. Although it's a very ubiquitous use case, it's still a pretty expensive use case. So in front of me now, this is an example of one of our fully 3D printed robotics kits.
Oh, cool.
And we built out the environmental sensors, the motion controllers, and we essentially designed a low-cost robot where you can 3D print the body. And what we're doing now is that we're building lessons and skill sets around things like, this is a replica of an electric vehicle, an autonomous vehicle.
Okay.
And so now the kids can build experiences where they can, if they're more of a mechanical engineering background, they can design and build and manufacture the chassis. If they're in the computer sciences, they can build the algorithms to kind of control it and make it make sense, right? And make it perform tasks, basically. But the cool thing is that now, since all of these sensors work in very similar software solutions, I can build experiences that use one or more of these at the same time.
Wow. We are really doing smart TV today on HBCU Nation. This is pretty cool. Let me ask you a smart question.
Sure.
How do you get your devices to students? Where's your customer base? How do you
get? In two ways, yeah. So, idealistically, we would be the ubiquitous framework across, every K-20 classroom, right? But that's a very political and hard thing to do. So we do two things. One, our current focus is truly more of the after-school, extended day, and summer experience. Because we believe that's a cool ways where you can do things that are kind of aligned to what's being taught in the classroom, but have a little more flexibility. So that's really our focus. So as an example, this past summer, we had a partnership with United Negro College Fund, and here in Atlanta, Clark Atlanta University, and we ran summer camps. Literally, we ran for the first time ever 3-week residential camps for middle and high school kids, where they stayed on campus for 3 weeks on a college campus. And we actually also then brought in 4 teachers per cohort for professional development.
On an HBCU college campus.
Exactly. So one of the things we're working on now is imagine a standard by which almost every HBCU has summer pre-college programs, right?
I'm liking that.
So can you imagine a day where we're partnering with HBCUs to bring this tech to these campuses in the summertime for these pre-college experiences? And then the goal would be then to leverage the kids that are on campus as a part of the mentorship group. So in two ways, you're providing the kids access to the college experience. They get exposed to kind of real world tech. And then we're building pipeline and mentorship two-way for those schools. So that's one of the programs we're working on scaling. And we're working today to build a national curriculum for leveraging tech in that way. And I think that is sorely needed and not in place. So that's one model.
Oh, yes.
The second thing that we're doing is that for the traditional classroom, we have a number of distributors that we're lighting up actually Q4 and Q1 of next year, where they've been around for 70, 80 plus years, and they're taking on different variants of our sensors to kind of push as a part of their offering. And then on the collegiate side, actually really cool conversations we're having. Literally, I can't announce the name of the company yet, but we're working with a really large company that represents over 35% of college campuses now. And they provide like virtual lab experiences as a part of their offering. And we're working now to marry our sensors with their curriculum.
I wonder who you're talking about. I'm not going to
that can kind of go out as well. So working on that piece as well. So it's like those type things are happening. And last but not least, I'm working with major companies. So we did a hackathon on Microsoft's campus 2 weeks ago. And it was one of the first times ever we took some high school kids who had really no experience to computing. We took they were all kids who were part of the Red Tails group, which is like a group focused on becoming pilots. And so we took the MODI sensor, and we literally in a 3-hour session had them collect data, save it to the cloud, build a machine learning model that was doing anomaly detection, and have them build a closed loop system that was texting them if something was out of pocket. And so that was a really cool experience that Microsoft really took a liking to. And so my team is currently working to make sure that everything we have aligns to their entire toolkit. And we're talking through ways to be able to launch programs nationally with them as a partner. So it's a very multimodal approach. But ultimately, my true goal is not to be the face in front of this. I'm looking to go take organizations that serve youth. So if it's a NSBE or somebody who really is focused on engineering, youth, et cetera, I want to come in and kind of become that intel inside for them and the enablement and training and PD so everybody can touch it, because I don't want to be the limiting factor that gets kids exposed to it.
Well, wow, you sound like you have it all mapped out there.
It's mapped out, but the difference, I always talk and tell people, man, that the biggest thing that time is the only, issue we have right now. And so we got to work on it. And we'll be also working to get a team around us to scale. We spent about 6 years or so really building this tech, getting in place, we have intellectual property around these things now. And so now that the engineering pencils are down, we're focused on the application. So if we move into 2020, my team's complete focus will be on just building examples, right? Can you imagine the day when I come in and say, here are 30 examples that are grade level specific around this sensor, right? So now I can go to a parent who is excited and say, hey, even if your school is not leveraging these tools, right, you can take it home with you. And so to me, I want to build out this resource library that's bigger than most. And so even if this sensor costs you $50 or $60, like there's so many resources that come with it that you're almost amortizing the cost over infinity because there's so many lessons you can do with it.
Right. And video games cost that much if they still buy them like that off the shelf. I mean, one game costs.
There you go. So I want to be the place where kids can go. They can learn real world and applied skills that are focused on things that are tied to 21st century skills.
Right.
But they're hands-on, they're practical. And if I could have my way, what I would do is that for everything that I'm showing you, to your point earlier about companies and their influence and what they're doing, I want to go put together specific programs around every sensor tied to a company. So take this guy. This essentially is an environmental sensor. My dream with this sensor, I want to connect with Byron Allen, and I want to go and do lessons around weather, right? And I want kids that in high school talking about meteorology and how they can influence weather and how the barometers are changing. And
that was my dream career.
So why not have that? And here's a sensor that can make sense. We can push them toward that, right? If we had this sensor, a motion sensor, a Lockheed Martin, a Boeing, right? A lot of aviation-related use cases around things like this. If it's a plant sensor, there are a lot of companies out there that focus on plant science and things along those lines, and all these new industries that are coming up around growing leafy vegetables, right? So
or other type of green leafy stuff.
There you go. So all these green leaf companies, right? Here's stuff you can use to support that. If you're a fish, if you're Petco or you're somebody, you're dealing with fish and aquatics, right? Here in Atlanta, we're working with the Georgia Aquarium, right? So there are a lot of ways where if you focus on industry and where things are going and what their gaps are, we can build graduated experiences that go from up elementary, middle, high school, and beyond, where I can take this exact same sensor and I change out the tool set. So when you're elementary school, you're in Scratch, right?
Mm-hmm.
When you're in middle school, you're maybe starting to pull out some higher level programming, like maybe it's Java or C# or .NET, right?
Yes.
But then when you get to college, it's like, you know what, that's cool. You have this data, but now we got to go build these algorithms. We got to go and
Mm-hmm.
apply them. You got to do some
Right.
regression analysis. But the cool thing is that the sensor doesn't change, right?
Right. The sensor doesn't change, but the applications are endless. And
Yeah.
understanding that is awesome if, well, not if, when you get to the point where you have a coalition or your offerings are expanded, which you already have a plan in place to
That's
do.
why, yeah. So yeah, the key is, like I said, doing things like this helps because I keep saying that one of my biggest responsibilities is really having the world have the epiphany my team has every day, right? People come into the office and they see it and they're like, oh, that's cool, that's interesting, but it requires an hour-long conversation or for me to just go pull out my book bag, and because I always have the stuff with me, right? It's like, oh, that's cool, you made that, yeah, we have it, right?
Yes.
But in real life, I guess in real life, I would really be more of an introvert in real life. I just play like I'm not, because you have to if you run a business.
Yeah.
But over the years, people who come from humble beginnings really don't brag about what they're doing. You're doing it because it's the right thing to do. And so focusing on documenting what we're doing and telling the story is a bit different than me. And I think a lot of the things I've done on the company side, the company has taken the persona of me, which is like you just do it and get it done, but you don't document it. So I'm forcing myself now to more tell the story, because people don't know what we're doing. And I see that have a lot less, getting a lot farther along. So I'm very conscious of that now. And I think for me, getting to scale is critically important, because I don't think that people who have the resources to do things like that I'm showing you are thinking about this demographic of this community. Anybody who can make sensors and things like I'm showing
Not at all.
They're trying to go build trillion-dollar companies, and they really don't care about trying to focus on these philanthropic or educational experiences.
No, they're not. They're trying to do something that is profit driven.
Yeah.
And, for an industry that is profit driven. So how can I make your bottom line bigger so that I can make my bottom line bigger?
Yeah. And this is kind of one of those things where you can do good by doing well. Like the fact that I left Atlanta, went to college, learned how to write code, and got a technical skill has changed my family's trajectory for generations to come.
Well, that's
and
great.
I realized that if I could find a way to pull somebody else forward, they're going to have the same result. And so to me, that's my mission and my passion. I think that we can do things like this. That was a story yesterday, man, about just the impact of tech. Like Microsoft stock this year's up 50%. Apple stock is up 70%. Microsoft and Apple combined, their market cap is bigger than the entire consumer segment of the New York Stock Exchange.
Wow.
They're wealthier than like the next 2,000 companies, right? Through technology. And I think about our communities and like what big tech companies do we have, right? How we've gotten and obtained wealth in a way that we can go and run these programs. Most of the things, initiatives that we focus on, we derive funds from grants and, these philanthropic kind of opportunities, right? So to me, it's how do you find a way to build something that's scalable, that can change lives and build wealth, so we can run programs that truly impact our community. So that's this phase of my life is really focusing on that. Is how do you leverage your skill, your tools, and your resources to really pull somebody else forward with you.
You keep them to yourself. I mean, not keep them to yourself as far as not sharing your knowledge base, but you don't sign up with someone who is expecting something from you because they're giving you some funding or something like that.
Yeah.
That's how you build the wealth. You keep your gifts and you monetize your gifts, and it may be a little bit more difficult, but that's something that I applaud you for. And I wanted to ask you, how large is your team right now?
Well, this thing, so there are about 30 people across different things that we focus on now. At one point, I had about 75 people that worked for me at one point. And that was when I was really, the goal back then was to get up to 100 plus people. And, we literally were modeling the Accenture model, right? You're out trying to find work, you're trying to find people, you're just throwing bodies at work, and truly more of the consulting type of vantage point. Now that's really not the focus, right? I made a conscious pivot over the past 5 years to turn more into a product focused business. And so we have specialized teams around different places. So, as you can imagine, a very strong engineering team to build physical pieces. We have a strong software team, because that's really more my background. And now what we're doing is building out all the other pieces that we typically haven't focused on, the soft skills, right?
Yeah.
People that can get out and talk about things, that can build relationships. We have a very strong relationship with partners and people along those lines. And now it's all kind of coalescing together. So I think that
Cool.
people who don't know we exist, they will know more next year.
Will.
And I always joke and say, if you can discount us now, but you'll read about us later.
Definitely, because when I found you, I was like, "Whoa, I got to talk to this guy right here."
I appreciate it, man.
Cool
It's like you said, I think it's just taking the time to have the conversation. Is very, as you know, being an entrepreneur is very time consuming. I put a post out on social media this past week and saying, everybody wants to be a CEO, man, but they don't realize like some of the struggles and things that come along with that. We spend a lot of time heads down just doing the work. And I realized that I got to take more time to come up for air and just have conversations, because there's an amazing group of people out there who are trying to do this type of work. And in some cases, we aren't all connected. We're all solving the same issue,
right?
Trying to solve the same problem, but we're not combining resources. So I really have been having a lot of conversations with like-minded people to say, how do we collaborate?
Yes,
because it's a big issue, and it's a big country, it's a big world. So
it's a big world, it's a big country, and everybody isn't at the same point. So you've been doing this for what, 20 years or 20 plus years?
20 years,
and
yeah.
then some people have been doing it for 20 months, and they're still trying to.
The thing about it, the cool thing about it is that, like I said earlier, the difference between me and them is time, right? But you can't discount, because the ones that have been doing it for 20 months, the thing they have better than me is that their pitch deck looks better than mine, right? They have a whole team, have volunteers.
Maybe not.
Right? But we have different vantage points. It's like we all can win. We play ball together. Ultimately, for me, I'm not somebody who cares about the name and the brand. Frankly speaking, I'm more than okay at this point in my life. My kids are good. My family's good. I'm really doing this for people that are behind me, right? And so to get this to a place to where others can succeed, and it's something that becomes a lasting legacy, that is my most important attribute that I'm going after right now. If this stuff is not out there, we don't win. And for it to be sitting around in my drawer or in my office and have my kids get exposed to it, and there's a group of kids, one neighborhood over, who don't ever see this stuff, that's a travesty in my opinion.
Right. So we're gonna wrap up in a few minutes, but tell my listeners, viewers, how does one find you and your products, and if they are interested in learning more about what you have and what you do and the offerings, how do they find you guys, since you're so low-key?
Low-key, yeah. So I'm easy to find on social media. So Laron Walker is typically my handle. I'm more of a LinkedIn and Twitter type of guy, so you can find me there. The company, the website for the company is Mantis, like the spider, MantisEDU as an education.io. So MantisEDU.io. That's the website for the company. You'll see things there. We have a lot of videos and product descriptions that are there. And we're putting out a lot of blogs and things coming up at the top of the year. Yeah, so MantisEDU.io for the company, and Laron Walker on social media for me. And I'm always there. So
tell me about the name of your company. How'd you come up with Mantis?
Yeah, names are funny. So first of all, you try to find things that you can get a domain name for. But the Mantis was a play on the praying mantis.
I figured
that we can kill the competition, right? So that's where that kind of came
from. I know it's going to be that cutthroat, but yeah.
But it's like, but the thing about that, but in that case, I always tell the story about there are some interesting people in this space. So there are two categories of people that I see. If you look at in the education business, particularly around what we call probeware sensors, right? They're the legacy companies that are out there, and they're amazing companies, but they're really just focused on instrumentation, right?
Yeah.
They have a digital sensor, it goes to a screen, and it gives you a number. And even though that data is digital, you still got to go take it with a pencil and go put it on a piece of paper and do something with it, right? They're not focused on computing, which I think is an issue where we are today. The other class of company, actually, frankly, are companies that are toy companies that are trying to pivot education because the fad of the toy has kind of run its course.
Yeah.
And so they're convincing schools now that this thing can roll and blink and do something, and it's going to teach your kids coding. And so those are the two things that are happening. And so for us, when I say kill the competition, it's really about redefining this narrative and showing people a way on how these things should be done. And then more importantly, the other companies as well, are not focused on teaching core subjects, right? So we're coming in saying, how do we teach math, science, ELA, and physics? And computing is like a supplemental piece that attaches to that. At the end, the kid is learning what they need to learn and understand for proficiency, because if we're not aligned to those standards and those approaches, the teacher's never going to embrace it, because ultimately they're being held to a standard where the kid has to get through this syllabus or this course. Right. If you're not part of that core curriculum, this stuff is not going to be embraced. And so that we're trying to redefine that narrative and show that this is the way it should be done. And I think that a lot of people who haven't either gone through an education system at scale or ever taught before don't realize those things are critical. They think we just come in and bring in a whole new framework, and it's never going to fly that way.
Yeah, and the parents don't get all the information they need either. I think
the parents don't know. Like, they see a commercial and, you know, abcsomething.com, and they're excited about it, but they don't really know, because they don't have the background in some cases as well. I think that's an issue. People who are making the decisions around what our kids get exposed to or what we're embracing as a standard aren't engineers, they aren't scientists, they aren't physicists, right? They haven't applied it, and there's a huge disconnect. And unfortunately, most companies who can influence and help to guide this conversation, they're only picking up the conversation when a kid gets to college.
Right.
So they're not going back in the pipeline. And so it's like, you can claim that what you have is not the product that you're looking for, but you're not really involved early on because you haven't been supporting this pipeline. So I think people are starting to understand that. But I think for me to be able to go into a room, to be able to speak to it from a vantage point of an educator, if I needed to speak from that vantage point, for somebody who's run a business, for somebody who actually has, you know, worked in industry, having that multimodal skill set that's cross-functional is unique. And I think that it allows us to be in conversations that other people can't really jump into because they haven't been thinking about these problems in that way. Yeah,
that is true, because you talk like a scientist and an engineer. So I modified mine a little bit for different audiences, but
funny.
It's not a bad thing. It's just
I have to go watch it now, because I've tried over the time to.
I'm good. What I was gonna say was, back to the parents.
Sure.
Is I was gonna ask you, when I asked you about your team, I was wondering if you had technical writers or people that wrote about what you guys are doing.
We haven't, and that's
what write about it for the people that need to know it, and in terms they can relate to.
No, a point well taken. We haven't, and that's okay. And that's what 2020
work on that.
For us. That's what we're working on now, because for us, I want a parent to go to my site when they realize, like, this is for my kid, and I can
and read it and understand what you're saying, and
if you know somebody, somebody's listening who has that skill set, you know, Laron Walker on Twitter and LinkedIn, reach out to me. Let's have that conversation.
Yeah, we taking job applications.
Yeah, send it over. You know, we got to build a
sample of your writing as a parent and a techie. But seriously, we do not do that well, and that crosses a lot of boundaries, though. And this is another show, but even in the medical field, for example, people don't understand medicine, and they'll tend to believe whatever they hear from a doctor, whether it's right, wrong, good, or bad, in their best interest or not.
The doctor said it. He had a lot of school.
Doctor said it. Same thing. Same thing. You know, kind of with the STEM-related subjects and applications and STEM camps and all of that. And I'm not saying that all STEM camps are bad STEM camps.
But a lot of them are.
Mr. Laron Walker can say that on Beyond the Classroom with Dr. Trina Coleman. I can say it sometime too, but yes, a lot of them are, because they follow a standard model. Not only that, I have said this, general education degrees, which is what most teachers have, do not equip them with the proper skills to do that application-based science stuff.
I think most of them, as well, always a good analogy is that unfortunately a lot of the camps are more driven by their profit model, and in most cases, most of the camps that we send our kids to in the summers are glorified babysitting operations, right? The kid goes there from 9 to 3, and that camp person goes out and buys some curriculum. Is going to probably be a Lego Mindstorm robot
or some slime.
Right, and they're going to go and do something. And again, for a lot of kids, it's a cool initial experience. But the real challenge becomes this: if that kid is in let's say the 5th grade, and they're in a camp, like if you take kids in the 5th and 6th and 7th grade, they're probably in the same cohort in the camp experience. So they go year 1 and they experience that camp, and they go year 2. Guess what? It's going to be the same camp, right? The rigor doesn't change, the experience doesn't change, right? And the kid is in the back, but literally that's what's happening. And I think, and the people that are running those camps most times are fresh graduates, maybe just taking an intro to engineering class or something, and they're there because they know how to turn a computer on and open a browser. And so
they played with whatever that was in the kit.
That's it.
And they know how to do the kit. And
so my goal is I want to change that experience, build that curriculum out at scale, provide that training. And I know that I can build an ecosystem of professionals and teachers to help do this in a different way, and allow for this stuff to happen in a seamless fashion, so that the people who actually understand it, who are the subject matter experts, are guiding these conversations. And because the last thing we want to do is have these kids who are forming their perceptions on what these things are to have a really bad experience and kind of discount an entire industry or profession because of an experience that wasn't well rooted. And I think that we don't realize that they're watching and they're making evaluations on these career paths. If we don't get them excited, then if we turn them off, then we could lose an entire generation of people. So I think that is a critical issue we have to address.
I think so too. And the 1 week camp once a year, that's not enough. I mean, you play with some stuff and you're like, "Ooh, that was cool." And then some corporation may show up with a large in scale check, not large in money check. And you take a picture and they're like, "Oh, we did this camp at such and such a school or whatever, and it was powered by corporation."
That's why I think, to me, that's what I'm saying. That's why I like the idea. So the camps we did this summer, they were 3 weeks on campus, but they now end up being to where we actually, in the high school, as an example, here in Atlanta, South Atlanta High School, we got approval from the school to where we get 1 full day each month.
Wow.
8 hours where we get to go and work with those kids during the month, and they're all working on continuing on these projects. And now we're working on a scenario for the 9th grade kids. We're trying to design a course to where the type of stuff we're describing today is actually a part of a course that kids take when they're on campus. So to me, we got to extend it to what's happening during the school year and keep it continual, and that something becomes kind of a check-in. And just like much of the college campuses, we come in, like when I was at Tennessee State, we came in this program called ECI, Engineering Concepts Institute. We all came in a summer pre-college program, and it was ironic that we were on campus for 5 weeks before our freshman year. Do you realize that we still, just like you said, class of 96 or 98 or 2000, whatever, we identify with that group. Like everybody talks about ECI, right? Because we were all there together. So imagine these kids, and they're a part of these continual summer experiences. They kind of identify with each other, and then they go to college or go to work, they have that sense of community that they take with them.
Yes.
And that matters a lot, because that community piece matters. When you're having an issue, having that community, somebody you can trust, really matters. And I think that we're not building community amongst the students, and then we're also not building allies with outside of their community, so people in the industry that they can connect to. Because one thing I have found is that professionals, people who are working, like, we want to give back, right? We want to support. We just ask the question the wrong way. And that's the point I would tell teachers. Like when I was at Tennessee State, we would go and tutor, and the principal would always say, I can't find enough tutors to help me support my programs. And I was like, well, you're asking the question the wrong way, because what people will say is, I need somebody to tutor 40 hours a week, instead of saying I need 40 hours of tutoring, right?
Right. It doesn't have to be one person. Yes,
exactly.
As long as the 40 hours are covered. Yes.
So we have mentors that can support. They can come by and run a coding camp and teach a class and do something. If you figure out what they're doing, align to what their passions are, and you show any adult who's in a profession, a kid who's doing pieces and parts of that and aspires to be that, and I'll show you somebody who's motivated to help the person get there. And I think that link is very easy to kind of connect if these programs are structured. So I'll stop. That's my thing, man. This is a place I really enjoy being. But that's my passion. You can see it, and I think
I do, and I know my viewers and listeners see it too. You're fully committed.
That's it.
500%. And I know that doesn't officially make sense mathematically, but it is obvious that you love what you do, and you want to make a difference, and you are making a difference.
Thank you.
I want to get my hand on some of those sensors. Oh my goodness.
I get information offline, and I'll get you some sensors so that Next time I'll interview you, and you can show me how, you can tell me your experience.
We're gonna flip the script.
We're gonna flip
Beyond
it.
the classroom.
I'm gonna call and see, yeah, how you're able to go and take this hands-on sensor and apply some of the things you've been teaching for years, and how you do differently with it.
All right, and that's what we do. That's how we do, and that's one of the things that I'm excited about as well. Being able to talk to people like you on the platform that I have to bring information to the HBCU Nation and whoever else supports the HBCU Nation, because things are happening that are relevant. Laron Walkers are out there doing stuff that we don't know about.
Yeah, we're here, yeah. And I would ask anybody who's listening, like you mentioned, anybody on the college campus, I love to partner. My goal is to have these experiences across every HBCU campus, right? So anybody who's responsible for the pre-college initiatives, things that are serving youth, serving kids, I will want to support that. And then even people who are running classes on campus, these lab classes where kids are getting hands-on experiences, right? That is a focus that we're working on. And I have a lot of industry partners I can bring to the table. And I really want to make sure that our schools are healthy and that our kids are getting the experience they need. So please reach out. Let's have a conversation, and let's do something. Let's do something quick.
Yes, quick is the operative word, because it's a race, and if we're not at least competitive in the race, we're not gonna place, let alone win. We're not even gonna place, and we're gonna win. We're gonna win the race. All right,
let's go play some ball. I'm ready.
All right, let's do it.
Thank you.
All right, well, thank you for coming on Beyond the Classroom, and until next time, start taking essential measures.